Hello, professors. Today we will be sharing about our OOP group project. I'll be sharing with my team members Ainsley, Jovan, Zhenming, and Dao Xing. To begin, we will share a statistic that fewer than 15% of high school students globally understand the concept of gravity. This is unexpected considering the information available online and the foundational nature of gravity in our science curriculum. This gap really underscores the need for innovative educational tools. Therefore, we have developed Learning Space, a game designed to bridge this knowledge gap in a compelling and interactive manner. So our initiative really targets the key demographic, secondary school students. This focus allows us to tailor to the local context, ensuring relevance and impact. Furthermore, our approach is grounded in implicit learning. This means that the students will gain knowledge naturally as they engage with the game without the need for direct instruction. Throughout the gameplay, they will intuitively start to understand complex concepts, making the learning process both effective and enjoyable. Our game is also engaging, as it engages the students with captivating and exciting visuals and enhances memory retention through the experiential learning. Our game is also encouraging, as it provides easy access to learning about space and gravity. It motivates students to continue exploring and learning in this field. In conclusion, Learning Space is not just a game, it's a transformative educational tool that makes learning about space and gravity intuitive and accessible for all students.
All right, thank you very much. So for now, I'll be discussing about the design pattern of our game. So in terms of learning space, what we actually focus on will be two aspects of the design pattern, mostly creation aspect. The first thing that we used was the factory design pattern, which will then promote scalability and reusability. In terms of scalability and reusability, this can be seen in the different enemy class and the different entity class. So what factory means is that we will have one of the class specializing in creating the different objects and entities. We will then have different entity classes to then store their own designs. So how we then progress is the entity to have their own design, and we'll have the factory to then output this design to draw out the output. So this will then promote scalability as in terms of wanting to advance and adding more features. We can then improve this factory to then increase the scalability to make an advanced and more ideology aspect. In terms of reusability, this can then be inferred into our design pattern, as in our program, we can then reuse this factory to then create many more entity classes and also objects to then be able to facilitate a bigger scale of growth. We will also then use singleton. So singleton definition will be the single instance to be globally accessed. So this can be seen in our scene manager class. So for our scene manager class, this can be inferred as scene manager will be in charge of storing the scene and displaying the scene output. However, many different of the classes will then call for this scene manager. So scene manager will be responsible for its own output. So access will be showing the information to be accessed. Different classes then can call for this class, for this scene manager class to then be able to show reusability, as this can be able to, for many different classes to use this one data set. And you don't have to create different scenes to be played many different times, where with this scene will be just be played in the scene manager. And different class will then just have to call this scene manager to then be able to use the scene manager scenes. This will then promote reusability.
Talking on the improvements that we have made to our game engine. So for our two improvements that we have made, the first I'll be talking about is the TMX map loader. So at first, if you can see on the left, it's actually our previous code when we were trying to load the map, the terrain, the different entities that we have. And what we had to do was actually we had to create and pinpoint the exact locations that we wanted to render each sprite at. And this can be very troublesome and confusing, as we have to manually track and implement everything. As you can see from lines 36 to 41 is all just creating terrain, and this was just a flat line. And if you want to explore in bigger maps, it will be a very big hassle, as there is a lot that we need to do. So to streamline and improve this process, we have actually made use of a TMX map loader, and we leveraged on an app called Tau, and as you can see from the bottom right, and this significantly increased the way that we rendered our map and build our game around. So it can be very easily improved or changed by a developer in the future. If they want to improve or change the way the game looks, it can be very easily done through a drag and drop manner. And as you can see, the code is also significantly cut down, as is this is the way we want it to be, as it's very reusable and easy, not just for the game developers, but also for users. If, for example, they want to change something in their game, or they want to have an experience trying to develop and build on the game, they can do so quite easily. Next, I'll be talking about the animation of characters and sprites. Previously, we were using static images throughout our entire project, and we felt that as we are targeting secondary school students, they might find it a bit stale and boring, as most games, everything is animated. And to get their attention and to also make sure that they really enjoy playing our game, we decided to implement animations into our game. So as mentioned previously, it was static images. Now for our player animations, we actually have we create a loop for the character. When press left or right, they will actually see the character running, or when they press the up key, they can see the character jumping. So this was done looping through various images so that it creates a animation style that is very appealing to the user, and it helps user engagement as well. It can also be very easily changed. Like previously, a static image, you just need to change the image file. But if I have 4 new different characters that I want to put in, I can just change the current file, and it's as easy as that. So it also helps in code reusability, as next time if a developer wants to change something, it can again be easily done. So next I'll be moving on to talk about the static images. So static images are not based on player input, but rather they are time loops. So there's a time loop that goes through to give the effect that, for example, a coin is spinning. These are actually ways that will significantly increase both user experience and also game development, as it is very easy to do so. For example, they want to change the color of the coin, or they want to change the color of the chest. It can be easily done so just simply by replacing the images. So for example, if we have 4, currently we have 4 chest opening images, so they just need to change the game developer just needs to change this, and it's done.
Moving on to our unique features, we have 3 different worlds: Earth, Mars, and Venus. Each world in the game features unique educational cutscenes, TMX maps, and environmental characteristics generated using different box 2D variables such as gravity and velocity. Within each of these worlds, they also feature signboards and treasure chests, scattered throughout the world, each consisting of facts and quizzes unique to their world. When a player approaches a signboard, relevant information is displayed on screen, offering valuable insights or hints. Once the player moves away, the information gently fades, allowing them to focus on the path ahead. This mechanism ensures that knowledge is imparted seamlessly throughout the game, enhancing the player's experience. After interacting with the signboards, there are treasure chests guarded by NPC enemies scattered across the map, each containing a quiz that challenges players' knowledge. These quizzes require the application of information learned from signboards, turning every piece of knowledge into a potential key to unlocking the chest. Solving these puzzles not only tests players' retention, but also contributes to dismantling barriers that guard the final flag. Hence, the win-lose condition. The win condition in the game is to clear all the treasure chests, which will open the border surrounding the flag. The player must then locate and touch the flag to clear the game. To lose, the player can drop down from the map, get touched by enemies on the sides, or fail to clear the game within the given time shown on the timer in the HUD.
We have reached the end of the slides, but before we end the presentation, let's take a look at the demonstration of our final game. I'll be moving on to the Eclipse IDE now and running the game at the moment. So this is our game, the learning space, and you can see on the menu screen I can go up and down. I can select the instructions and it will show me that I need to collect the coins, I need to kill the enemies, I need to find the signboards, I need to solve the treasure chest, and also I need to reach the flag at the end. Right, let's play the game now. If I selected Earth, it will show me a few information about the planet itself, the third planet, the planet to support life, and the gravity to be 9.8 meters per second square. So now let's say I can kill the enemies. You can see that I added score. If I reach the signboard, it will show me information about the planet itself, right? So for example, if I were to go up here, there's another signboard here. I kill the enemy first. You can see that Earth supports diverse ecosystems. So this is an information that we will be educating the player or secondary school students, our intended target audience. Now I'm collecting the coins. You can see that on my top left corner, the score is increasing as well, right? Now let's say I kill the... Okay, what support Earth's life form? So when you reach a treasure chest, it will prompt you with a quiz that you need to answer. So based on what I learned, it will be ecosystems, right? Now I've solved the treasure chest. Take note that there's actually 3 treasure chests in every single planet. So this is the second one. What geological feature is active on Earth? Well, that's a simple one, or it's a hard one, called tectonics. Now, If you see that right now I've cleared two chests, this flag border doesn't open, I couldn't reach the flag. So I need to find the final treasure chest now. Where could it be? So it's actually here. So I need to clear the enemies, I need to get it. Okay, what is unique to Earth's atmosphere? It will be oxygen. Now I've answered all the treasure chests. Now I just need to reach the flag. You can see that the border is gone and I can reach the flag and you win. Now another thing is that we have prepared several planets, for example Venus. The difference is that the gravity value is different. So you can see that the player may have some difficulty in controlling the player. Right, so it may jump overboard, it may jump too little, and if you control it badly, you may actually die. So that adds a thrill to the game itself. So that's all for the game that we have created. This is all the time from P11T5. Thank you very much.